Right, in this lesson we're going to talk about a tangent. If you remember, a tangent is a line that goes past a circle and intersects that circle at one singular point. So it's just like bouncing off the atmosphere. So tangents have a certain relationship with a circle. In this case, a radius, when you have a radius or a diameter that intersects with a tangent at the point of tangency, right, that's the point of tangency, then they are perpendicular to each other. So if AB is tangent to circle O, then line AB is perpendicular to segment OP or radius OP. Okay, and don't be fooled too. If it's a diameter all the way across, it doesn't matter. Okay, anytime you have the diameter or a portion of the diameter and the tangent intersect, they're going to intersect at a right angle. So anytime you see a problem that has a tangent, so usually always, if it appears tangent, then it is tangent. We will not give you one that looks like it could be possibly tangent, but that it isn't, okay? So as soon as you see that tangent and you see that diameter, you want to go ahead and label that right angle because it will give you the direction as to where you want to go with the problem next. It helps in your problem solving strategies. Because as soon as you label this right angle, this tangent DE, once you see that tangent, you recognize that this is a right triangle. Now that you know that it's a right triangle, you can find out, it says, what's the value of x? Well, x is this angle. Well, normally we would do the angle, right, as equal to this arc minus this arc. But we don't have it. Now, there are ways that you could do it. I can show you how it works. Okay, but if we just use the fact that this is tangent and that this triangle adds to 180, we know that these two are complementary. So if we take 90 and we subtract 38, we'll find out that x is 52. Now, just so that you can see it, we have this inscribed angle right here. That is 38. So the angle is half the arc. That means that the arc is 76. So that arc is 76. This is 180, this arc on this side. So if we find that angle, if we want to go about it this direction, then we would do half of this arc minus that arc. 180 minus 76 is 104, divided by 2 is 52. So you do have alternatives, but we've got this nice little triangle right there, and it is a right triangle, so we can just use it. It all works out. The math is going to math, okay? It's going to take care of itself. Okay, number 2, Tina calculated that the measure of angle P is 147 degrees. Is she correct? And why or why not? Well, one of the first things that I look at when I notice this is don't get so caught up in looking at lines and circles that you forget about the shapes that they create. That is a quadrilateral, and in fact, it is a kite. We know it's a kite because these two consecutive sides are congruent, and then these two are congruent for a reason that we're about to talk about. Okay, but that is a kite. Well, we know that kites add up to 360 degrees. We also know that radiuses and tangents are perpendicular to each other. Well, those angles should add up to 360, but these 90 plus 90 plus 147 plus 36 is 363. It's too much. It's supposed to be 360. So no, she's not correct. One of those angles is wrong. Okay. These tangents, that has to be 90. So one of them, 147. If she calculated the 147, then the 147 is wrong. Okay. Number 3, we have circle A shown on the right. If the measure of angle ACB is 45 degrees and AC is 10, then find the lengths of the sides. So ACB is 45 degrees and AC, which is this entire length right here, is 10. It wants to know how long is AB and BC. Well, this is one thing that goes back to those special right triangles that we talked about back in like January, February, in that we're talking angles, but just because I mention an angle doesn't always mean we're talking about angles and arcs. AB is a segment, BC is a segment. Okay, so what we want to do is we want to recognize that that's a 45. If that's 45, and we know that the radius and tangent are perpendicular to each other, we know that's also 45. Well, that creates a 45, 45, 90 triangle. Now, the way that I taught you to do this originally is, remember, we would say that's x. If you look on your formula chart, our ratios are 1, 1, root 2, or x, x, x root 2, x radical 2. And so the way that we originally learned to do that, if you recall, is to put x over 1, because that's the legs, and 10 over radical 2. Set up that proportion, because we learned this with similar triangles. X over 1 equals 10 over radical 2. When you cross multiply, you get that x is equal to 10 divided by radical 2. Okay, we also learned that you're not supposed to leave radicals in the denominator, so we need to rationalize that denominator. So let's make it go away. Let's rewrite this so it's an equivalent fraction. So we have 10 radical 2 over root 2 times root 2 is 2. And then that 10 over 2 cancels and leaves you with 5 radical 2. So AB is 5 radical 2. And if AB is 5 radical 2, so is BC, because it's a 45, 45, 90. Now, another way you could do this is your x root 2 side, right? If you look at your formula chart, this is your x root 2 side. So you could say 10 equals x times the square root of 2. Well, if you divide both sides by radical 2, look at where you are. You're back here. So it doesn't matter if you use the equations that are on your formula chart, the x root 2, or if you set them up with proportions. I would like for you to get to the point where you can just memorize. If this is 10, that's 5 root 2. If that's 5, then it's 5, 5, 5 root 2. And so just learn to follow those patterns, and it makes them go quick. That's the point of 30, 60, 90, and 45, 45, 90, is they are intended to be shortcuts. Now, a second question says, what if AC is 12? That's the hypotenuse. What if AC is 12? Let me redraw it since I wrote all over the other one. It's perpendicular. AC is 12. BC is 9. What is the radius? So the radius is here. That's AB. The radius is there. Well, that's a Pythagorean theorem question, because we have that right triangle because the radius is perpendicular to the tangent. A squared, or x squared, plus 9 squared is equal to 12 squared. You might be tempted to do a 3, 4, 5, but it's not, because the hypotenuse has to be the 5, or the multiple of 5, so that doesn't work. Subtract 9 squared, 12 squared minus 9 squared. A squared is 63, or A is equal to 3 root 7, right? Because if you take the square root, let me bring it over here, the square root of 63, right? If we break that into a perfect square and its multiple, the square root of 9 is 3, the square root of 7 is not a whole number, so we leave it alone. 3 root 7, or 7.9, depending on whether you are asked to leave it as a simplified radical or a rounded decimal. Okay, then we've got this one. This one's a little more complicated. It's not bad. The idea behind it is easy. You just have to be careful with the algebra. AB is tangent to circle P. There's a reason that I told you that, and that's because you need to recognize that the radius is perpendicular to the tangent. That creates this right triangle. I have the sides of a right triangle, which always is going to take us to Pythagorean theorem. Now, this is x, and this is also x, because I need the whole side to be able to do Pythagorean theorem. So the whole hypotenuse of the triangle is x plus 8. Now, here's where you have to be careful. X squared plus 12 squared is equal to x plus 8 squared. I guarantee this will be where you make the mistake. Remember that x plus 8 squared is x plus 8 times x plus 8. Okay, so we have x squared plus 144 is equal to x plus 8 squared is x plus x times x, and you've got 8x plus 8x, which is 16x, and then 8 times 8, which is 64. This is the part you'll forget. You'll do x squared plus 64, and you'll forget the 16x. Notice that the x squared and the x squared are going to cancel out when you collect your like terms from either side. So that's nice. They're going to go away. And now you just subtract your 64 from both sides. You get that 80 is equal to 16x. See, if you had lost that 16x, then you would be in a quandary because you would end up with 144 equals 64, which is never true. Divided by 16, and you get that x is 5. That's what I asked for. That's what I found. So the radius of that circle is 5, and the length of the hypotenuse is 13. So this is a 5, 12, 13. Now another thing that triples do, or not triples, that tangents do, is if you have two tangents, what we know is that the two tangents are going to be equal to each other. Two segments that are tangent to a circle from a point outside the circle. So we're extending two lines from this point, and they're tangent to this circle. And what we get is A is equal to B. This is useful in using satellites. You have a satellite floating above the Earth. It can see this much of the Earth over here, this much of the Earth over here. Okay? And what we know is that those distances are the same. A is equal to B. The length of segment A is equal to the length of segment B. We call this party hat because it sits on top of the circle like a party hat sits on your head. Okay? So whenever you see two that come here, and we're talking about the segments, this is different than what we did before with angles, right? When we did angles, we used this theta, and remember we would do half of arc M minus N. At this time, we're talking about the segments. We're actually talking about the sides of that angle. Before, we were talking about the interior, the rotation of that angle, and then the pieces of the circle. This time, we're actually talking about the segments that form it. What's the length of PW for number 6? Assume that segments that appear to be tangent are tangent. So even if they kind of look, it's hard to draw tangents where they only hit in one place. So what we know is that this is that party hat, looks like a party hat. If you have a hard time, you can turn it sideways so you can see it. That means those two are equal to each other. 3x minus 6 is equal to x plus 10. When you go through and you do the algebra, you get that x is equal to 8. Subtract x from both sides, add 6 to both sides, you get that x is 8. But I didn't ask for x, I asked for PW. PW is right here, so it is 3 times 8 minus 6, so you get that PW is 18. Consequently, QW is also 18 because it's 8 plus 10. And they're supposed to be equal to each other, and they are. Okay, last one, number 7. Quadrilateral SHOW is circumscribed, which means written around. Inscribed means written in. Circumscribed means written around, around circle P. WO, so this entire side, WO is 14. HM is 4. SW, this whole thing is 11. And ST is 5. So what this is 4 separate party hat problems. Okay, now be careful. This is not necessarily, it could be split in half, but it is not always split in half, okay? So you have to pick a place to start. It doesn't matter where you start, just find a place, but think party hat, where it's the same on both sides. You've got the point of your party hat sitting on your head. That means, say for instance, if this is 4, then this is 4. If this is 5, we've got our party hat right here. Right? If that's 5, that's 5. Let me do this party hat. We've got this party hat here. So we've got 4 party hats going on. Okay, so 4 and 4, 5 and 5. Then we've got this party hat. Well, we need to know those lengths. Well, I gave you the whole side. If this is 5, then this must be 6. If that's 6, that's 6. Then I gave you that whole thing was 14. Here's this party hat right here, the whole thing. So the whole thing all the way from W to O is 14. This piece is 6. That means this piece is 8. This piece is 8. So you can do 2 of 8 plus 4 plus 5 plus 6. 2 8s, 2 4s, 2 5s, 2 6s. And you get that the perimeter of that quadrilateral is 46. Big takeaway. Anytime you see a tangent and a radius like this, always draw in that right angle because you're probably going to need a right triangle in some shape, form, or fashion. And anytime you have two tangents that touch the side of the circle, it's like a party hat. They're going to be equal to each other.